Welcome to the session Garnish and Serve Your APIs in 45 minutes. My name is Mike Budzyński and I'm a PM for Azure API Management. This session is a role-play exercise in which you are the engineer for the Tailwinds Traders company. The company has an existing asset, which is a website which shows information about a conference. However, the management of the company figures out that in order to make the business succeed, they need to create new revenue streams. And to create new revenue streams, they need to build an ecosystem around that website. And this can be done via productizing the asset, the website, via APIs. As an engineer, you need to do a few things to accomplish that goal. You need to decouple the API from the implementation. You need to protect the API from abusive behaviors and abusive users. You need to accelerate the API to reduce the perceived latency. You need to serve the API to API consumers. You need to monitor the usage and errors of your API. And lastly, you also need to keep the extensibility options in future if you want to extend the architectures of your API. This sounds like a great project for a year, but the management is really harsh. You have only 45 minutes to accomplish your goal. I'm going to help you and guide you through all the steps that you need to do. To visualize, this is what you are trying to achieve. There is an existing website, the icon in the middle, which is powered by Azure App Service, the icon on the right, and the website has existing users, the website visitors. Your goal is to increase the audience of the data that you're showing, potentially to partners or application developers who will build applications in multiple different environments on multiple different devices. You also need to consider potentially that this website might in future be powered partially by other services, like for example Kubernetes or serverless technologies like Azure Functions. The perfect way to achieve that is to use API management to aggregate all of your APIs. API management consists of three main components. The management plane in top right corner, which is exposed through an API, but the most common interface is Azure Portal or PowerShell. This is where you as an API provider will configure your API management service and all of your APIs. The key component in API management is API Gateway, the one at the bottom. API Gateway is a mediation layer that serves all the API requests and responses. It is a proxy layer. And lastly, there is a developer portal, which is a website which surfaces all the APIs to application developers. The first step is to decouple the API from its implementation. We'll do that in the Azure portal. This is my API management service, Tailwind 2020. I can go to the APIs section to import APIs from various services or API definitions or create a blank API. In this case, I will import an API from OpenAPI specification, but you can also perform the same action by linking your app service from its own view in the Azure portal interface. In our case, this will be the demo conference API, and this will be its name. I will also link it to a gateway, which I will explain in the later part of our presentation. As you can see, the API has been successfully imported, and I have a few API operations that this API provides. The next step is to protect and secure the API. By default, APIs in API management are secured with API keys. However, our goal is to protect the API from abusive behaviors. We want to protect it from users that might be bombarding it, for example, with millions of requests in a matter of seconds. As you can see, I already have API management extension installed in VS Code. I can browse all of my APIs. In this case, is the API that I have just imported. I can expand it and see the policy file. Currently it's empty. Before I add the throttling policy, I want to see how the API behaves if I try to bombard it with API requests. As you can see, all the requests succeeded, which is not what we are trying to achieve. Therefore, I will apply a throttling policy on my API. Just rate limit by key, limit it to 10 calls every 10 seconds, and increment it based on the IP address of an API request. Save the file, wait for it to upload to my API management service. The changes have been uploaded. I'll wait for a second for it to propagate. And now I can test the API again. As you can see, only 11 requests succeeded and 89 have been throttled. It means that our throttling policy is working as expected. The difference between 10 and 11 comes because of the distributed nature of API management. The Visual Studio Code extension also allows you to browse all of API operations and configuration of your API management service. The next step, after protecting and securing our APIs, is to accelerate them with caching. Because our APIs serves mostly static data, which is the information about conferences, we can cache it to reduce the perceived latency to the API consumers. So if the API response is cached in API management, the request will not be forwarded to the backend services, and it will be served. The response will be served directly from API management. This allows you to both reduce the latency as well as reduce the strain on the backend services, which in turn means that you can downgrade your backend services and save on the cost. Let's see how it can be applied in practice. This time, I will use the Azure portal to apply the caching policy. I will use the getSpeakers method, where I will apply a caching policy. I will cache it for 3600 seconds. And as you can see, there is various options that you can modify, but we'll just go with the default. In fact, caching policy is two policies. It's a cache lookup policy and a cache store policy on the outgoing response. Let's try to test it. I can test my API from the Azure portal, and as you can see, I got the response. The response latency was 500 milliseconds. Now if I try it again with caching, the response latency is 58 milliseconds, meaning that I reduced the latency tenfold with only one click by adding a caching policy. Once you import your API, you protect and secure it, you accelerate it with caching, you are now ready to serve it to API consumers. You can achieve that with a developer portal. Developer Portal is an automatically generated website with the documentation of your APIs. It is built into API management service, but if there is some requirement that this portal doesn't satisfy out of the box, you are free to take the open source code, which is hosted on GitHub, fork it, build on top of it, and self-host your own flavor of the portal. So either you can use the basic scenario with the built-in portal, or you can further build on top of our product yourself. It's also DevOps friendly, meaning that you can automate its migration between the environments. In our demo, we'll try to customize our developer portal to match the Tailwinds Traders brand. We can access the developer portal from the overview blade of API management in the Azure portal. This is the default look of the landing page of the developer portal. I'll upload a few images that I prepared for this session. Which is the background image and the logo. Both have been uploaded. And now I can try to customize my portal. First, I will replace the background image to match the new one, the Tailwinds brand. I'll remove the contoso. Welcome to Tailwinds Traders. This can stay as is. For the sake of simplicity, I will also remove a few of those sections. Make it a really simple landing page for our Tailwinds Traders. I can also change the color to match the Tailwind Traders brand. This is the design panel of the application portal where you can customize all of the visual elements used in the portal. For example, colors, typography, gradients, shadows, buttons, forms, cards, images, video players, and more. I will change the Azure Blue color to Tailwind Traders color. And I'll keep the rest as is. I can also change some of the layouts in my developer portal to replace the Contoso logo that is used across it. Instead, I'll use the Tailwind Traders. I'll resize it to, let's say, 120 pixels. Make sure it's not too large. Save the page. And now I'm ready to publish my portal. I can now access the portal as a visitor, as an API consumer or application developer by opening it in a different session. For that, I will use the private browsing mode of my Firefox browser. As you can see, all of the styling that we did has been applied. So there is the new color, there is the new image, there is new color also in the menu section, and there is no other content on the landing page. If I go to APIs, I can see the API that I have just imported, which is the demo conference API, and I can browse its specification. I can see all the API operations, and if they were better defined, all the schemas and headers and query parameters, everything would be displayed here. Also, if I were signed in as an application developer, I would be able to test my API in the interactive console and alternatively copy a snippet of a code to write an application in a very short manner. After you serve your APIs to API consumers, you want to make sure that those APIs are not abused. Even though we already applied the throttling policy, you still want to see what are the usage patterns on those APIs. Another reason why you want to do that is maybe there are certain APIs that are not used at all. In that case, you can just deprecate them. As an engineer, you also should explore any errors that the API might be throwing, any exceptions. API management has a plethora of observability options that you can use. For the purpose of this session, we'll focus only on two of them. The built-in reports allow you to see the patterns on the usage of your APIs. So not only you can see the raw requests, but you can also see them aggregated by users, by client geographies, by subscriptions, etc. This means that you can monitor the times, you can monitor the bandwidth, you can monitor the cache hits and misses, and more. With application insights, you'll be able to track any errors in your pipeline and find the bottlenecks, potentially even using distributed tracing across the client application, API management, and the backend services. Let's start with the API analytics functionality, which is built into every API management service. For that, I can navigate to the analytics section of my API management service and see all the requests and data transfer of all the API calls within the last hour. I can also browse the geographies of client applications. In this case, I'm recording the presentation from the United States. I can also see the breakdown of requests to an API. Potentially, I could also explore how the API operations are being used, what's the latency, etc. You can also take a look at the raw requests, which provide you raw information about all the API requests and responses. This information can be also exported via the REST API if you want to do any data analysis on top of it. Now onto the application insights. This is my application insights instance that's linked to the backend service and API management. As you can see, API management, you can explore the logs, and for example, all failed requests have common properties. That's worth exploring. Or alternatively, we can investigate the failures. As you can see, all the failed operations, 354 out of 400 are for the operation get speakers, which is the one that we tested. The failure is 4 to 9, which is the throttled. That's because we ran the artillery program, which was trying to bombard the API, and our throttling policy kicked in. So in fact, this is a red flag to raise our awareness, but it means that the service is behaving as expected. Once you publish your APIs to external API consumers and monitor them and analyze the usage, you may want to think about future extensibility options. Nowadays, many enterprises adopt hybrid or multi-cloud architectures, meaning that in the case of hybrid, certain part of your services is hosted in the cloud while others reside on premises in your own data centers. With multi-cloud, the cloud services can span multiple clouds. This is especially common in industries like retail, manufacturing, banking, etc. As you can see, if your API management service resides in the Azure cloud, all the API requests need to go through the API gateway component in the cloud, even if the client applications are in the same environment or location as the backend services. Like for example on the right, on premises, the client application needs to make a call to the cloud, and then the cloud redirects the call back to the backend services on premises. This is not very optimal, of course. In April 2020, we announced the general availability of a new feature called Self-Hosted API Gateway. This feature allows you to deploy the API Gateway component wherever you want to deploy it. In this example, it is deployed in other clouds as well as on premises. So for example, in the top right corner, you can see that the API requests can arrive directly to the API Gateway component hosted on premises. If the client application is also on premises and the backend services are also on premises, it means that all the data, all the traffic resides and remains within the boundaries of the on-premises servers. This both reduces the latency and bandwidth, which can also be charged for in terms of cloud services, and sometimes also allows you to stay relevant and compliant when it comes to internal compliance requirements or regulations. The self-hosted API gateway is functionally equivalent to the managed gateway. It is packaged as a Linux-based Docker container image, and it can be deployed anywhere Docker is supported. So for example, on your desktop machine, you can deploy it using Minikube. In production environments, you can deploy it using Kubernetes. It needs to be connected to an API management service in the cloud to pull down the configuration, for example, a list of APIs, policies, etc., and push up the telemetry. The required connectivity is only the outgoing connectivity. Let's see how it works. This is my Visual Studio Code environment, and as you can see, I already have a gateway called Tailwind 2020 localhost. And the API that's assigned to it is the demo conference API, the same API that we imported. I have a Minikube cluster running on my machine, and as you can see, it has the Tailwind 2020 localhost API gateway already deployed in it. And there is also two URLs. One is HTTP, the other one is HTTPS. So first, just to make sure it works, I can make the call to the API gateway in the cloud. As you can see, it succeeds. And now I can try to make the same call to the API gateway that's hosted on my local machine. And it also succeeded. So I was able to make a call from a local machine to my local API gateway, which could potentially use my local backend service, but in this case, in our scenario, it actually still forwards the call to the backend service in the cloud. We've done it. We were able to use API management to decouple the API from its implementation by importing it into API management. We protected the API with a throttling policy, and we accelerated with a caching policy. We served it to application developers and API consumers with a built-in developer portal in API management, which we also customized to match the branding of Tailwind's traders. We also monitored the usage of our API with built-in analytics and with application insights. And lastly, we extended the architecture to a hybrid scenario where API Gateway was running on my local host machine. API management is an established service serving hundreds of billions of API calls every month. These actions are the most common actions and the best practices that tens of thousands of our customers follow. As a next step, you can add a custom domain to your API management service, and you can import more APIs to better leverage the capabilities of API management. As your APIs evolve, you may want to introduce new versions and revisions to properly manage them throughout their lifecycle. Enterprises often choose to secure the APIs with auth protocol, which allows you to use JWT tokens with an expiration time instead of static API keys. So once a secret is leaked, it is better if it's a JWT token because it will be expired after, for example, half an hour. You can apply other policies like side calls to other services or transformation policies to manipulate the request body, response body, headers, query parameters, and more. You can integrate API management with Azure Monitor to set alerts on particular metrics. Azure Monitor also allows you to set automated actions based on the alerts, so you can configure auto-scaling rules on your API management service based on an alert on the capacity metric that API management exposes. If your application developers are using the APIs from different places around the globe, you might want to consider geo-distributing your API management gateways. You can either do it with the self-hosted gateway, or you can use the built-in multi-region feature of API management, which allows you to distribute API management gateways, the managed one by the service, into any Azure region. You should also configure automated backups and streamline deployments of your API management service configuration changes with DevOps processes. This will also allow you to create multiple environments such as development environment, testing environment, production environment, or even more of them. And lastly, you can isolate API management with private networking features. If you would like to learn more about API management, go to this website, https://aka.ms/apim-lab, which contains a list of useful resources such as recordings from conference sessions, blog posts, GitHub repositories, and more.